In our last two lessons, we learned about the lowest common denominator, lowest common multiple, as well as equivalent fractions. Today, we're going to be learning how to add and subtract fractions. There's an important rule you have to remember when you add and subtract fractions. Fractions can be added or subtracted only if they have the same denominator. So let's underline those keywords. Only if they have the same denominator. The first question we're going to look at is question A. We're going to have to find the sum of 3 over 4 and 1 over 2. As you'll see, these fractions do not have the same denominator. Therefore, we have to manipulate these fractions such that they have the same denominator. Before we add these two fractions, we have to make sure they have the same denominator. This has a denominator of 4, this has a denominator of 2. Clearly, they are not the same. We're going to have to find the lowest common multiple of 4 and 2. I've gone ahead and listed out the multiples of 2 as well as 4. And as you can see, there is a common number. That number is 4. And this is the lowest common multiple. You might also notice that 8 is common, but it is not the lowest number. I'm going to write an equivalent fraction for 3 over 4. This new fraction has a denominator of 4. You have to ask yourself, how do I go from 4 to 4? All you do is you multiply by 1. What you do to the bottom, you also have to do to the top. So you're going to multiply the numerator by 1. 3 times 1 is 3. We're going to do the exact same thing for 1 over 2. The new fraction is going to have a denominator of 4. You're going to have to ask yourself, how do I get from 2 to 4? You multiply 2 by 2 to get 4. What you do to the bottom, you have to do to the top. So you're also going to multiply the numerator by 2. And 1 times 2 is 2. We're going to rewrite our question using the equivalent fractions we just determined. We're going to use 3 over 4 and 2 over 4. Because these two fractions have the same denominator, we can go ahead and add them. So we're going to look at the numerators. 3 plus 2 is 5. Now, this is a common mistake. A lot of students actually add the denominators. So 4 plus 4 equals 8. This is incorrect. The denominator stays the same. So it remains 4. Many students will actually write their final answer as 5 over 8. This is a common mistake, as I've mentioned before. Do not touch the denominators. The actual answer is 5 over 4. And you'll notice that this is actually something called an improper fraction. I'm going to show you now how to quickly convert this improper fraction into a mixed number. If you remember, a fraction basically is division. So we're actually going to take 5 and divide it by 4. You have to ask yourself, how many times does 4 go into 5? It goes into it 1 time. So 1 times 4 is 4. You're going to find the difference, which is 1. So you have a remainder of 1. The number you got up here actually becomes the integer, and the remainder down here actually becomes a numerator, and the number over here becomes the denominator. And our final answer is actually 1 and 1 over 4. And I'm just going to put a little box around my final answer. In our second example, we're going to look at 3 over 8 plus 1 over 6. Before we can do anything, we have to look at the denominators. And you'll notice that the denominators are not the same. Therefore, we need to find the lowest common multiple of 8 and 6. I'm going to go ahead and list out the multiples of 6 quickly. 6, 12, 18, 24, 30. I'm going to list out the multiples of 8. 8, 16, 24, 32. At this moment, you should notice that the lowest common multiple actually is 24. So 24 is the LCM. Using this LCM, we can actually write equivalent fractions for 3 over 8 and 1 over 6. So let's go ahead and do that. So I'm going to write 3 over 8 equals that, and I'm going to write 1 over 6 equals that. Now I want you to take a look at the left side. The new denominator is going to be 24. At this point, you have to ask yourself, how do I go from 8 to 24? Well, you multiply 8 by 3. What you do to the bottom, you also have to do to the top. So I'm going to multiply the numerator by 3 as well. So 3 times 3 is 9. I'm going to do the exact same thing on the right side. So the new denominator is going to be 24. You're going to have to ask yourself, how do I go from 6 to 24? You multiply 6 by 4. What you do to the bottom, you also have to do to the top. So 1 times 4 actually is 4. And what we've done is we've written equivalent fractions for 3 over 8 and 1 over 6. I'm just going to circle that with a black pen. At this point, I'm going to rewrite my original question using my equivalent fractions. So I have 9 over 24 plus 4 over 24. Because the denominators are equal, you can go ahead and add these fractions. So let's look at the numerators. 9 plus 4, and this is a common mistake. A lot of students add the denominators. You do not touch the denominators. The denominator remains the same, so it remains 24. So let's go ahead and make some more space. At this point, we can go ahead and simplify 9 plus 4, which is 13, and the denominator stays the same. At this point, you need to ask yourself this question: is 13 over 24 reduced? Well, we can go ahead and check that by finding the greatest common factor of both 13 and 24. So the factors of 13 are 1 and 13, while the factors of 24 include 1, 2, 3, 4, 6, 8, 12, and 24. As you can see, the greatest common factor here actually is just 1. And if you divide 13 by 1 and 24 by 1, nothing happens. It remains the same. So 13 over 24 is, in fact, your final answer. In our final example, we are going to add 5 over 6 and 3 over 7. Before we can do that, the denominators have to be the same. But if you look closely, the denominators are not the same. They are different. Therefore, we're going to have to find the lowest common multiple of both 6 and 7. So let's quickly list out the multiples of 6. We have 6, 12, 18, 24, 30, 36, 42. I'm going to stop there for now. Let's list out the multiples of 7. 7, 14, 21, 28, 35, and 42. What you'll notice is that the lowest common multiple here actually is 42. And I'm just going to write LCM beside that number. Once we found the LCM of 6 and 7, we can go ahead and write the equivalent fractions for 5 over 6 and 3 over 7. So let's set that up. Okay. And 3 over 7. We know that the new denominator is going to be 42. You have to ask yourself, how do I go from 6 to 42? You have to multiply 6 by 7. What you do to the bottom, you also have to do to the top. So 5 times 7 is 35. We're going to do the exact same thing to the right side. The new denominator is going to be 42. You have to ask yourself, how do I get from 7 to 42? Well, you have to multiply 7 by 6. What you do to the bottom, you also have to do to the top. So 3 times 6 is 18. So we've just written an equivalent fraction for 5 over 6, which is 35 over 42. And we've just written an equivalent fraction for 3 over 7, which is 18 over 42. At this point, we're going to rewrite our original question using our equivalent fractions. So I have 35 over 42 plus 18 over 42. And what you'll notice is that the denominators are equal. So we can go ahead and add these fractions. So let's take a look at the numerators first. I have 35 plus 18, and the denominators stay the same. So the denominator remains 42. Do not make the common mistake of adding the denominators into 84. Do not do that. That is incorrect. So we are going to simplify what we've just written. So 35 plus 18 is 53, and the denominator remains the same, remains 42. Before we finish this question, we have to look at 53 over 42. And what we have here is a improper fraction. We actually want to convert this into a mixed number. So it will contain an integer and a fraction. How are we going to do that? Well, we're going to take 53 and we're going to divide it by 42. 42 goes into 53 once. 1 times 42 is 42. You're going to find the difference between 53 and 42, which is 11. So that would be a remainder of 11. What exactly are we going to do with these numbers? Well, the 1 actually is going to become the integer. The 11 here is going to become the new numerator, and the 42 is actually going to become the denominator. Now you have to ask yourself the question, is 11 over 42 expressed in lowest terms? Well, the factors of 11 are 1 and 11, since 11 is a prime number. Both numbers are divisible by 1. However, both numbers are not divisible by 11. 42 is not divisible by 11, therefore you can't reduce this any further, and 1 and 11 over 42 is your final answer.